Hello students, welcome back to Max Beyond Marks channel video number 5. This is your Pragasham sir. In the previous video, we observed an interesting pattern between consecutive square numbers and afterwards we completed an exercise. Today we are going one step deeper into that idea. Have you ever thought a square number actually can be built using only odd numbers? Yes. In this lesson, we will discover how every perfect square is connected to the sum of consecutive odd numbers. We will also learn a very interesting repeated subtraction trick to check whether a number is a perfect square or not. And by the end of this video, you will be able to find the next square numbers instantly without multiplying. Now we are going to see perfect squares, how it is formed from odd numbers. It's a beautiful pattern. So only with the help of odd numbers, the perfect squares are going to be formed. Let you look at this. Here it is having only one circle under that number 1, that is 1 square. Let you observe the second one. In this slide, there are 4 squares, but already 1 now plus 3. That means odd number 1 plus odd number 3, but the sum it is 4, but that also that is 2 square, and also the diagram arranged is looking like a square. 4 dots is looking like a square. Now see this one. 1 plus 3 already was there, and now 5 more added, that goes to 9. That is nothing but 3 square. Okay, so here we are adding only odd numbers. 1 plus 3 plus 5. Odd numbers only added and it becomes 9. Here again 1 plus 3 plus 5 plus 7. That is equal to 16. That is nothing but 4 square. Next one, 1 plus 3 plus 5 plus 7 plus 9, it is 25. It's 5 square. Now in this, the same all the numbers up to 9 plus 11, that is equal to 36, but it is nothing but 6 square. Hence 6 square is 36, 5 square is 25, 4 square is 16, 3 square is 9, like that. That means we can conclude that sum of first n odd natural numbers equal to n square. It becomes a formula. Testing whether 36 is a perfect square or not. That is different. The first pattern what we have seen is different. In that what we have concluded is sum of n numbers, n odd numbers is nothing but its square. That means up to 1 plus 2, 3 plus 5 plus 7 means that is 4 square, that is 16. That is sum of odd natural numbers, n natural numbers is n square. Here this is pattern number 2. Like that you think, test whether 36 is a perfect square or not. So through which one you are going to test that one? It is a repeated subtraction. The name is repeated subtraction, but the process what I am going to do will be same like what you observed in pattern number 1. Now in pattern 1 we added 1 by 1. Now what I am going to do, there are 36 circles. In that I subtracted 1. That's all. So next I subtracted 3. It goes to 32. You can count it and there will be 32. Okay, next 32. Next that L-shaped one is being removed. That is 5 square circles are removed. It becomes 27. Now 7 is removed, subtracted, it becomes 20. And 9 is subtracted, it 11. And 11 is subtracted, it becomes 0. Hence, what they are coming to say through this pattern is that if it is a perfect square, like adding, if you go on subtracting one by one, the result is going to be 0. If it ends with 0, then it is a perfect number, perfect square number. Now you know 37, if I had taken, here will come remainder 1. Then you can say that it is not a perfect square. So what you can conclude, if the result becomes 0, it's a perfect square. If it comes other than 0, then it is not a perfect square. Now, two beautiful patterns we have seen. What is the first one? When you go on adding all the odd numbers, 1 plus 3 plus 5 plus 7 plus 9, etc., then you will get beautiful square numbers. Here, when you go on subtracting the odd numbers, then you will get 0 to check whether it is a perfect square or not. Now you know this is two patterns. We have seen two patterns now. Then what is the benefit of these patterns? There should be some use, no? So we will go with few sums based on this one. What type of questions are they going to ask? Shall we see? Yes, question number 1. How many odd numbers are added to get 81? That is a simple sum, so no problem, no need to worry. 1 plus 3 plus 5 plus 7, etc. Up to how much you have to add? Up to, okay, 9 numbers you have to add. Not, that's what I am thinking. Now here to get 81, it is 9 square, so you have to add up to 9 numbers, not 9 square, not up to 9, it is 9 numbers. That will get the answer as 81. Okay, so 1 plus 3 plus 5 plus 7 plus 9, 13, 15, 17, 19, up to 19 you have to add. Why? Okay, I'll write it. Up to 19 if you add, you will get the sum as 81. This is your first question. Find the fifth odd number. What is the fifth odd number? 1 plus 3 plus 5 plus 7 plus 9. So the fifth odd number is 9. 9 is the fifth odd number. Question number 3. If 35 square is equal to 1225, find 36 square. Now we know 35 square is 1225, means what is the 35th odd number? Okay, here there will be some number 1 plus 3 plus 5 plus 7, up to that some number will be there. So totally it is going to be, when you add all the numbers, totally it is going to be 1,225,225. So we want that 35th number to get 36 square. So what is the 35th number? To go get the 35th number, we'll take small examples. 3 square is 9. 4 square is 16. Okay, so here fourth number is, what is the fourth number? 1, 3, 5, 7. So 7 is the fourth number. That means, what is here fourth number means, difference is coming as 16 minus 9 is 7. 16 minus 9 is 7. That means what? n, that is 2 times of n, plus 1 or minus 1. Now we'll take positive itself or negative, no problem. So 35th number means 2 into 35 plus 1, that is 70, plus 1, that is 71 is the 35th number. You can see here, if I add 1, that will become 36th number. If I subtract 1, that will become the previous number, 35th number. Which number you want? 36 itself, if you consider, then it is 71. Now if I add 71 to this, then it comes 6912. Yes, the answer is correct. 1296 is the square of 36. Okay, 35 square is 1225. So we are having two chances, either 2 times of n minus 1 or 2 times of n plus 1 for the larger number and for the smaller number. Is this a formula? No. From pattern we created one method. That's all. Now we'll go to next question. Is 38 a perfect square? 38. We are going to say fourth question. Is 38 a perfect square? No, it is not perfect square. You know how? You just go on repeated subtraction method. 38 minus 1, 37. 37 minus 3, 34. 34 minus 5. Like that you go on doing. Then if you are getting remainder, then it is not a perfect square. If you are getting 0, then it is a perfect square. That's all. Likewise, if they're asking larger numbers also, you can do this, use this method and do the sums. Next question is, how many numbers lie between 3 square and 4 square? Let it be 13 square and 14 square, 42 square and 43 square, but it should be 2 consecutive numbers. Now for this also we will develop one formula. 4 square equal to 16 and 3 square equal to 9. I took like this. Then it comes, subtraction is 7. Same, one more number, 5 square equal to 25 and 4 square equal to 16. Here subtraction is how much? 9. Surely you know, because 3 and 4, 7 means 4 and 5 will be 9, the next odd number. So here also you can guess it, there also. So based on any method, that is what pattern it is called. So now how to get it? That is, here also same, 2n plus 1 or 2n minus 1 you can get. But how many numbers are lying between, they're asking. Okay, so that means 2n plus 1, if you take this number, and 2n minus 1, there will be 2n numbers. So what is the 2n numbers? Yeah, whether it is right or wrong, you check this one. What is the 2n number? 2n minus 1 and 2n, because between they said, no, how many numbers lie between, they are saying. So 3 square is 9, no? 10, 11, 12, 13, 14, 15, 16. 16 is not included, 15. Therefore, there are 6 numbers. That's what I said. 2n means if you take this 3, 2 into 3, that is 6. Then how many numbers lie between 11 square and 12 square? Now you can see easily. What is that? 11 square is, 11 is n now, 2n equal to 2 into 11, that is 22 numbers. You check this one. So whatever the number, bigger number it is, there is no problem, no need to worry at all. That's all. So here you know only 2 patterns you have seen, and from that lot of sums you are able to create. This is 5 example sums I took. They can ask as many sums as possible by changing the numbers and changing the meaning. That's all. The patterns only is going to be useful. Okay, I hope, my dear children, this video would have been useful for you. If you like this video, please subscribe to this channel and like. Also press the bell button to receive when and where I am uploading the videos. I'll try to upload maximum number of videos as this is new syllabus. Whether you like or not, please comment. That is very important for me. Okay. Till next video. See you. Bye. From your Pragasam sir.